right, so at the beginning of class here, let's see, where were we? We were at the end of this problem here. Alright, so we were here, we were down to where we were going to do the integral. Alright, so I think we ended up, we'll just start where we're doing the integral again. So we ended up with, we got 0 to pi, right? And then we had 2 plus 8 cosine squared sine. Alright, and then over here we had the square root of 4, so that was a 2. So we brought, and this was dt, so we brought the 2 out. And then I had to integrate this business here. So 2 plus 8 cosine squared t sine t. So the trick is when you want to integrate with the cosine and sine multiplied together, anything that's being taken to the power, that base of that's going to be your u. So in this problem right here, I'm going to make u equal to cosine t. That way my derivative of that is negative sine dt. So negative du is replacing sine t dt. So that's replacing the sine t. And if I had done it the other way around, if I made u equal to sine, you might be like, oh, well, that's easier to do du because it's just cosine. So yeah, this would take care of sine and one of these cosines, but what would I do with the other one? I'd be stuck, and so I can't do it this way. All right, so my integral of my cosine squared and sine is now becoming the sine dt. T dt is being replaced with a negative and a du, and then I got u squared. So we saw in class that was u to the third over 3 with a negative, so then that became negative, u was cosine, so cosine to the third t over 3. All right, so let's go back and put that here. So 2, I'll do my integral, that 2 is this one. Integral of 2 would be 2t, and my answer for this whole part and back was over here, so negative cosine to the third t over 3 from 0 to pi. Okay. All right, and oh, I lost my 8. 8 was right here too. All right, so let's go ahead. So I got 2. I gotta plug in pi. So I get 2 pi minus the cosine at pi is negative 1. So that's going to be negative 1 to the third. So 8, negative 1 to the third over 3. All right, so all of that minus when I plug in 0. Well, when I plug in 0, that's 0. Cosine at 0 is 1, so that's going to be 8/3. Okay, so let's see, I got 2 pi minus, that'll turn into negative 8 over 3, so plus 8 over 3. And over here, minus minus is plus 8 over 3. So my final answer, 2 times 2 pi plus 16 over 3. Okay, so whatever, you can make that 4 pi plus 32 over 3, or whatever you feel like doing, but is my answer. So this is my line integral. All right, so next we have this guy here. So we're going to do the same idea. Luckily, I am already given my x, my y, and my z in my in parametric form there, or it's already been parameterized for me. It's already a vector. So why don't we go ahead, so that's my r of t, so why don't we do r prime of t, because we are going to need that. So derivative of cosine is negative sine. Derivative of sine is cosine. And the derivative of t would just be 1. Okay, so I'm going to set up my integral. 0 to 2 pi. I have to plug my stuff in. I'll do that in a minute. Over here I want the magnitude of my derivative, so the square root, sine squared, plus cosine squared, plus 1 squared. Alright, so sine squared plus cosine squared is 1, so over here I just have radical 2. So when I write my problem, I'm just going to put a radical 2 in front of my integral. Alright, up here I gotta do y times sine z. Well, y is sine t, and z is t. So I have sine t times sine t. So y is actually sine t, z is the letter t, so I get sine t times sine t. So I got sine squared. So for my plan here, since I have sine squared, I'm going to need to use my power reducing formula. So the replacement for sine squared is 1/2 parentheses 1 minus cosine 2t. So I'm going to put the 1/2 out here, and then I'm going to put 1 minus cosine 2t. Alright, so just do this integral and we'll be all set. Integral of 1 is t, minus integral of cosine would just be sine 2t, but counteract the 2 by putting a 1/2 just in that part. Got to do this from 0 to 2 pi, and it's all multiplied by radical 2 over 2. Alright, so here we go. Plug in 2 pi. So luckily when I plug in 2 pi or 0, this part just goes away. The sine of 4 pi is 0. The sine of 0 is 0, so frankly, like, nothing is happening there. So basically I have radical 2 over 2. I plug in 2 pi, minus I plug in 2 pi there, it's 0. Minus when I plug in 0, I just get a big fat 0. And so when I multiply this together, I get radical 2 pi. Alright, so that is your line integral on this space right here when you're following this curve. Alright, so here's back where we were doing this earlier in class. Now we have to make up our own, the only harder part about this, we have to make up our, what's it called, our vector. So you remember in class we did this on the warm-up. The vector from 0, 0, 0 to 1, 2, 1, we were able to just know that if we start at 0, 0, 0, my vector just becomes 1t, 2t, and 1t. I basically kind of take the coefficients and it takes me in that direction. Okay? All right. So, r of t, I forgot enough commas here, so we're going to have t, 2t, and t. So my r prime of t I would like to know as well. So the derivative is 1, 2, and 1. Okay, so easy as that. Then we do the same thing we did before. We got the integral, we're going from 0 to 1. I'm going to have to plug these values into this problem here. So x squared will be t squared minus y, well y is 2t, plus 3z, so plus 3t. And then over here, the magnitude of the derivative, so square root. If you square all these and add them up, so 1 plus 4 plus 1 is 6. Alright, so radical 6 comes out. Integral 0 to 1, I got t squared plus t to do my integral. Alright, so my integral is t to the third over 3 plus t squared over 2. Evaluate that from 0 to 1, and when I'm done, multiply it by radical 6. Okay, so plug in 0 and nothing would happen. So plug in 1, I would have radical 6. I'm basically at 1/3 plus 1/2. So I get 5/6. So my answer is 5/6 and then a radical 6. Alright, on this next part. This next part is pretty much done for us. I just wanted you to see that if you have different parts, you have to break it up. So like when somebody says, hey, first you're going to follow this like parabola shape and then it's going to turn into a line. So all you do there is you basically just cost you more work. You have your parabola. So your parabola, your r of t for your parabola is t and t squared. So that's right there. So then your derivatives are 1 and 2t. So my derivatives right here, there's the magnitude coming to me over there. My function is 2x, so 2 times my x is t, so 2t. So there's my integral I'm doing. It's just an easy u substitution because the derivative of a t squared would involve a t. So I make this my u. So 1 plus 4t squared, the derivative is 8t, so I have to counteract with a 1/8. So since I already have a 2 out there, and when I put my 1/8, 2 times 1/8 is the 1/4. And now the t and the dt are there for me to, I should have put a dt here, are there for me to do my u substitution with for my du. And so I have the square root of u. Well, that's u to the 1/2 we would prefer. So the integral of u to the 1/2 is u to the 3/2 over 3/2, so times 2/3. I have my 1/4. So that cancels here. That turns into 1/6, and I put my u back. 1 plus 4t squared and to the 3/2. So you plug in a 1, and you get 5 in there. So that's where you're seeing this 5 to the 3/2. You plug in a 0, and you see 1 to the 3/2. That's where you're seeing 1 to 3/2 is 1, and then all over 6. So that's for the parabola piece. And so then you have to make up a vector for this piece right here, this movement. So our piece here, we got 1 minus 1 is 0, and 2 minus 1 is 1, so that's our next to t, plus our initial point is 1, 1. So like we did on our notes, so if we add those together, I get 0t plus 1 for my x, I get t plus 1 for my y. My derivative is 0 and 1. So for my magnitude of this derivative, I get 1. So it doesn't help, it doesn't do anything for me. And then over back here, I got to plug in for 2x right here. So 2 times x is 1, so 2. So I'm just doing the integral of 2. So the integral of 2 would be 2x, evaluated from 0 to 1, gets me 2. So when you're done, what you have to do is add those pieces together. So there you go. So if you have 2 different curves, you have to basically just do the line integral for each one separately. All right, let's see if we can I'll just introduce this next little part and then we'll see. All right, so another format for line integrals is when x and y are separated. These are called line integrals of your function f along c with respect to x and y. So your formulas now become this. They become, you got your function of x to t and y t, and then you got your derivative right there, and then dt, and then your y, so notice the dx here, and here's dy, becomes pretty much the same thing, but then you have y prime of t. So we're just going to follow this formula and do our line integral this way. And so it frequently happens that line integrals with respect to x and y occur together. So when this happens, you can abbreviate this by writing it this way. So notice that, what's the difference here? Hang on. Like I literally wrote the same, oh, so I'm sorry, this has the integral twice and this has it once. So this is how we end up writing it. So just pay attention to what goes where in the next one. It's pretty simple, but this dx and this dy are going to be important as well. All right, so this is when our problem is given to us like in a different format. So, you know, problems we just did were given to us like this and had ds over there, and then we changed it and made it all t's. So now our problems are going to be given to us like this up here. Now this last page, this is just another couple pictures of line integrals and so forth. So I was just another picture that was, they can be positive or negative. So they're positive if they're above the xy plane, and if something dips down below, that's why your line integral would be negative, because underneath, just like when you did integrals back last year. All right, so let's do this problem here. All right, so we have 2 parts. So we'll just finish this problem and then we'll do the rest on next class. So section 1 here. So section 1 is going from -5,3 to 0,2. So if I subtract those, 0 minus -5 is 5, and 2 minus -3 is 6. Two minus -3 is 5 also, sorry. All right, so I got 5t plus, I'm starting at -5, -3. So that means I got 5t minus 5 for the first part. And then I have 5t minus 3 for my second part. All right, so we have to do our line integral there. So we are going to go from 0 to 1. Remember, we're using this setup right here. So just look at what it says. It says y squared. So we are going to do this thing, and we're going to square it. So I have 5t minus 3 squared, and then it says dx. So the derivative of the x part. Well, the derivative of the x part is 5, and there's a t, so we're going to put 5 dt, and that's how we get the t back. All right, plus, then I have my integral, 0 to 1 again, but now I have x, which is 5t minus 5, and then I have dy. Well, the derivative of y is 5 again, but it's a t, so it's 5 dt. So now I can write this as one big integral. So if you square this out, I get 25t squared. Multiply these together, I get negative 30t plus 9. So this is going to be one big polynomial, right? Because I'm adding these together. They're the same integral. So I end up having 25t squared. Negative 30t plus 5t is negative 25t. And 9 minus 5 is plus 4 dt. Okay? And they both had a 5 in front of them, so that 5 is still out here. All right, so when you integrate that and multiply by 5, you get negative 5/6. All right, so this next little section right here is this parabola, 4 minus y squared. Now, you don't always have to use t. If you want to, if it's easier for you, we could make this into t. We would probably do t and then 4 minus t squared. We would do it like that if we wanted to make a vector out of it. But we could just use y. We could do this. We could have, you pick your y, and x is 4 minus y squared. Okay, so I'm just going to show you how to do it that way. So I have my integral, so then I can keep these numbers here, negative 3 to 2. And then I follow the problem. It says integral, I got y squared. So here's my y, I'm going to square it. So I got y squared. And then it says dx. So what's the derivative of the x part? Well, the derivative of the x part is negative 2y dy. Okay. Plus, then I have the next integral, same thing, negative 3 to 2, or you don't have to write that. And then it says x, so x is 4 minus y squared, times, and then it says dy. So the derivative of y is 1, and then dy. And so now it's like one big problem for us to do. All right, so let's clean this up. I got negative 2y to the third. Over here I have 4 minus y squared. So together we'd have one big integral, negative 2y to the third minus y squared plus 4. All of it with dy. And so that's just an easy polynomial to do. I'll just tell you the answer is 40 and 5/6. Well, remember we want the whole grand picture, so we have to add these together to get the whole motion of going to, of doing the whole thing. Sorry. And so if you add those together, you get 40. Okay? And that's it. We will finish the rest in class. Actually, why don't you do this for me? Why don't you see if I gave you the pieces right here. Why don't you do this next one? This is a 3D one, but it's really all just the same as we did before, just expand it to there. So just go to right here, just do this example number 6, and then we'll catch back up and finish the rest in class next time. Okay? All right. Adios. Bye-bye.